Hello, my name's Emily Mitchell, and I'm representing my colleagues from the University of Nottingham and the University of the Highlands and Islands to introduce our project for the landscape decisions, developing a statistical methodology for the assessment and management of peatland, also known as StAMP. Peatlands appear in a lot of out-of-the-way places according to this map. They are up in hilly areas or mountainous areas, and they are quite often in lowland agricultural areas. So why should we care about them? Well, in fact, if you look at this map, you will notice peatlands cover 10% of the UK land area and deliver key ecosystem services. Good quality peatlands are really good at maintaining carbon. However, degraded peatlands instead emit carbon. 80% of UK peatland is degraded, accounting for 4% of our annual carbon emissions. Peatlands are also really good at maintaining water quality and quantity, which has implications for drinking water, suppressing downstream flooding, and balancing estuarine and coastal water quality. They also provide a wetland habitat to nurture biodiversity. As a result of this importance, the UK has a strategy called the National Peatland Strategy, which is designed to restore and conserve UK peatland, and this is internationally supported by the IUCN Peatland Programme and the IUCN Peatland Code, which provides a framework for investment into peatland restoration. There has also been a huge commitment of at least £900 million from the United Kingdom. As a consequence of this investment, we would like to measure the success of peatland restoration by providing the statistical basis for monitoring, reporting and validation to enable strategic investments from both government and private investors. We use spatiotemporal data from Sentinel-1 satellite radars, measuring the deformation of the land surface to produce a time series for each location, like the example shown here. We develop a new statistical method using the Obiect Oriented Data Analysis framework for these time series to assess the initial condition of the peat and the change in surface motion after restoration. This allows for quantified evidence of the restoration progress and a better understanding of management decisions. We are currently developing this over Scotland, but it also has the potential to be expanded across the whole of the United Kingdom. Based on the Object-Oriented Data Analysis framework, we have classified a site in the Flow Country in Scotland according to the peatland condition. Here we find three different classes: badly damaged peatlands in black, peatlands of poor condition in red, and peatlands in good condition in blue. Good peats have a steady increase in height with consistent annual oscillations. Poorer peats have the potential to become good peats from their oscillations. Our method successfully identifies the pool system labelled, a natural well-wetted area found from ground observations. Our method also successfully finds other areas with good peat and areas to prioritise restoration. Once an area has undergone restoration, we also look to quantify how well the restoration technique worked, again using the Object-Oriented Data Analysis framework. In the time series example shown, the peat was classed as damaged until restoration took place at the change point. We then see if the peat has responded well to restoration, i.e. the peat is now classed as good, or has a small response to restoration, i.e. a poorer peat, or remains damaged. If the latter, then a different restoration technique may be required. There are many peatland restoration techniques that can be used, but selecting the best technique suited to the peatland is often difficult. Here we look at forest to bog restoration undergone in the four regions indicated with the letters A, B, C and D. Regions A, B and D appear to have improved after forest to bog restoration. However, the improvement is yet to be seen for a large proportion of peats in Region C and will require further monitoring. Taking this approach enables resources to target a peat once we are confident it is not responding to restoration, and to facilitate enhanced decision making to measure and predict the peatland system. Thank you for listening.